Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's easy level puzzle. And remember, take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Anyways, the puzzle today is called Thermo Killer by P.S. Nin, and here are the rules. The standard Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and box. Digits on the thermometer increases along the line starting from the bulb. So this is a thermometer, and it goes to, I guess, all of these things. I guess it forms some sort of like an crossing of swords or something. I don't know. So the thermometer goes this way. Hold on. Let me pause to make sure this is actually what the thermometer is. Hold on. Okay, yeah, it's the same it's the same picture. So unfortunately, I think this is the bulb of the thermometer. These are the bulbs of the thermometers here. And it always increases from the bulb to the tip. So that means it must increase from here to here. It must increase from here to here. It must increase from here to here. Same with this one. It must increase from here to here. It must increase from here to here. It must increase from here to here. So a valid thermometer would be, for example, say you had, this was 2, and this was 3, and this was 7. And then this could be 5, 6, 9, whatever. So this is always increasing from the bulb to the tip. So this would be a valid thermometer. And those are thermometers. And the bulbs seem to be on the corners, and the tips are everywhere else. So those are thermometers. The number given by the cage's corner is the sum of all the digits in the cage. So for example, these 3 digits must add up to 24. These 2 must add up to 14. These 3 must add up to 21. These 2 must add up to 12, etc., etc. So if this were, for example, a 5, this would have to be an 8 so that they add up to 13. And those are these are called killer cages. So therefore, that's why this puzzle is called Thermo Killer, because you have killer cages and you have thermometers. And X connects 2 digits with a sum of 10. So, for example, if this were a 7, this would have to be a 3 to add up to 10. So because these 2 digits have to add up to 10 because of the X in between them. Same with this one, and same with this one, and same with these 2. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so first things first, we have 2 cages which have 3 unique digits which add up to 24. The only possible set that works there is 7, 8, and 9. So this is 7, 8, and 9, which makes this 1, 2, or 3. Therefore, 3 can never be in any of the corners because it would have to be 3, 2, and 1 for that to work. So it could be 1, 2, and then you could have 4 in any of the corners. This obviously has 3 digits that are greater than it, so it must be 2 through 6. Similarly, and also in addition, we have 7, 8, 9 with triplet in rows 2 and 8, so the rest of the rows cannot contain 7, 8, or 9. So this is also 2, 3, 4, 5, or 6. This is also 2, 3, 4, 5, 6. This is also 2, 3, 4, 5, 6. Let's see. This can be however, this can be 5, 6, 8, or 9. This can be 5, 6, 8, or 9, but it can't be 8 or 9 because we have a 7, 8, and 9 triplet in box 2. So this can't be 8 or 9, which means this is 5 or 6. If it's 5 or 6, it has to be with an 8 or 9. So this is 8 or 9 here. Let's see. What else do we have? 21. There's 3 unique digits that add up to 21 on both columns 2 and column 8. You could have the lowest possible digit you can have in that cage is a 4, because it could be with 8 and 9, right? Which adds up to 21. So this is 4 through 9. Obviously, it can't be 5 with this two-digit set that adds up to 10, because 5 would have to add up with 5, and that would violate Sudoku rules. This is also 4 through 9, but we don't know what specifically we have here. Okay. Let's see. These are at least 4. So it's 4 through 9. Oops. 4 through 9. This is 4 through 9, and this is 4 through 9. This could be 1, 2, 3, 4, 5, technically. These are 1 through 5, and this is 1 through 5, and this is 1 through 5, because these have to be 2 through 6. Okay. Let's see, what else do we have? This cannot be 7, 8, or 9. So this is 2 through 6, because you can only have 2 and 9. The minimum for 2 digits adding up to 11 has to be 2 and 9. So therefore, this is 5, 6, 7, 8, or 9 here. Interestingly enough, this must contain one from 6, 7, 8, or 9. Right? If that's the case, one of these is from 6 through 9. I think you have to have, well, okay, if you have 4, 8, and 9. Okay, this is also 4 through 9, right? This has to be 4 through 9, because you can have, at minimum, 4 and 9, which adds up to 13. This is 3 and 9, 4 and 8, or 5 and 7. So this is 4 through 9. This is 4 through 9. This could be 3 through 9. This can't be. This is 1 through 6. These are 1 through 6, and this is 1 through 6. So same here. This is 1 through 6, 1 through 6, 1 through 6, 1 through 6. One of these has to be. So say it's 4 and 6 here. Okay. So these are all highs. This is a low. This must be a high. These are all highs. We don't. One of these is a high, one of these is a low. We don't know anything about the rest of it, though. If this is 4 and 6, this must be 5, 7, 9, which makes this an 8. And this is 5. So that works. This can never be 1. This can never be 1. This can never be 1. It can't be 2 either. So this could be, this is at least 3 through 9. This is at least 3 through 9. So this cannot be 7, 8, or 9. So this has to be 1, 2, 3, 4, and 6. This same here. This is 1, 2, 3, 4, and 6. Which means this is 4, 6, 7, 8, 9. This is 4, 6, 7, 8, 9. Okay. That seems valid. Hmm. This is 1, 2, 3, 4, 6. Um, hmm. What does that mean here then? Let me drink some of my brain juice here. Hmm. Hmm. Interesting. So at least one of these two has to be 7, 8, and 9. If one of them's 4 and 6, the other one has to have a 7, 8, and 9 in both of the spots. If they're both not 4 and 6, though, hmm, what does that mean? Hmm. This is 3 through 9. 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 Does that tell us anything? Not particularly. What happens if we have 1 and 2 in the corner, right? That means obviously this can't be 1 and 2. So this cannot be 3 here, if that's the case. Hmm. That doesn't really tell us much. Hmm. If, on the other hand, this was 6, that means 7, 8, and 9, 7, 8, and 9, 7, 8, and 9 are here. These two would have to be the corresponding 7, 8, 9s here. Right? Because this can never be 7, 8, 9. Those two are 7, 8, and 9s. They have to be in row 8 here in box 8. So therefore, in box 9, it has to be in row 9 because they would be here. So this would be 7, 8, 9, 7, 8, and 9. This would also be 7, 8, 9 because so therefore it's with 1, 2, or 3. And this is 1, 2, or 3 with 7, 8, or 9. And this would be 7, 8, and 9 also. Hmm. Does that tell us anything, though? Not particularly. Hmm. Yeah, I'm not seeing the interactions very well here, I guess. This is obviously 8 or 9 with 5 or 6. Hmm. This doesn't tell us very much either. We know 7, 8, 9 cannot be one of these two. Cannot also be one of these two. So there has to be a 1, 7, 8, 9 in one of these 3 cells. Similarly, there's 1, 7, 8, 9 in one of these cells, and there's 1, 7, 8, 9 in one of these 3 cells. Hmm. Whatever this cell is cannot be here. Obviously can't be here because it's one of the 7, 8, and 9s. Can't be here. So it's one of these 3 cells. It also has to be one of these 3 cells. But that doesn't really tell us much either. Hmm. What we do know about this one is, okay, so for 21 cell, or 21 sum cell, sorry, 21 sum cage with three digits, you always have to have 2 out of 7, 8, or 9, right? So it could be 4, 8, 9, it could be 5, 7, 9, or it's 6, 7, 8. So you always have 2 out of 7, 8, and 9. Does that tell us anything? I'm not really sure. Hmm. Oh, interesting. Okay. We know In row 9. Interesting. Okay. Say one of these pairs of 10 that add up to 10 must be, say one of them's 4, 6. If one of them's 4, 6, this can never be 7, 8, or 9. The other one has to be 1, 2, 3 with 7, 8, or 9. But this can't be 7, 8, or 9. This can't be 7, 8, or 9. Therefore, where do the 7, 8, and 9 have to be in row 9? It would have to be here and here. But because of that, we know this is 7, 8, or 9. One of these is 7, 8, or 9. We know there's two from 7, 8, or 9 in this 21 cage and 2 in this one. Therefore, 7, 8, and 9 cannot be either of these two, right? And it cannot be either of these two. Because the rest of the 7, 8s, or 9s has to be in, 2 of them have to be here, 1 is already here, 1 is here. Therefore, the rest of the columns in 2 and 8 cannot contain a 7, 8, or 9. Which is interesting then, because if that's the case, so say this was not 7, 8, or 9, and this can't be 7, 8, or 9, where are the 7, 8, or 9s in these boxes? It has to be, can't be here, can't be here, can't be here. Therefore, this must be 7, 8, or 9, this must be 7, 8, or 9, this must be 7, 8, or 9. Same here. These can't be 7, 8, or 9, these can't be 7, 8, or 9, so this has to be 7, 8, 9, 7, 8, 9, 7, 8, 9 in box 3. But the problem there then becomes there has to be 2 from 7, 8, 9 in row 3 for box 3. There's also 2 from 7, 8, or 9 in box 1 on row 3. So that makes 4 cells which must contain 7, 8, or 9, but that's only 3 digits for 4 cells. So that's not possible. So you cannot have both of these be 7, 8, or 9. One of them has to not be 7, 8, or 9, which means both of the 7, 8, or 9s have to be here. So therefore, you cannot contain a 4 and a 6 here. So this has to be 7, 8, or 9, and this has to be, one of these has to be 7, 8, or 9. So you have one 7, 8, or 9 here, or one 7, 8, or 9 here, but not both 7, 8, and 9s being here. So we know then one of these is a 7, 8, or 9. We don't know what the other one is. It has to be non from 1, 7, 8, 7, 8, and 9, right? So if this is 7, 8, or 9, this becomes 2 from 7, 8, or 9, which means none of these can be 7, 8, or 9, which means this has to be 7, 8, or 9. Or if this is not from 7, 8, or 9, we know either that's 7, 8, or 9, and we have 2 from 7, 8, or 9. So therefore, so either you have 2 from 7, 8, and 9 here, because neither of these can be 7, 8, and 9. These can't be 7, 8, and 9, so this must be 7, 8, 9, 7, 8, 9. Therefore, they must be here. Therefore, 2 of them must be here, which means this is 7, 8, and 9, and this is 7, 8, or 9. Which means obviously the opposite can't be 7, 8, or 9 here, because there's 2 from here already, there's 1 here already, and therefore this can't be 7, 8, or 9, this can't be 7, 8, or 9. Or this is 7, 8, 9, and this is 7, 8, or 9, because none of these could be 7, 8, or 9. So this is 7, 8, 9, this is 7, 8, 9, this is 7, 8, or 9. These two must be in this set, so they have to be in row 1 for box 1. So they have to be, that has to be 7, 8, or 9. So either this is 7, 8, okay, so in either case, I think therefore this must be 7, 8, or 9, right? If this is 7, 8, or 9 here, obviously this can't be, these can't be anymore, and these can never be. So either this is 7, 8, or 9, or this is 7, 8, or 9. If this is a 7, 8, or 9, these can't be 7, 8, or 9, these can't be 7, 8, or 9, these can't be 7, 8, or 9, so this must be 7, 8, 9, 7, 8, 9. which means they have to be here in row 2. And therefore, in row 1, where can these two cells be? They can only be these two. So they would have to correspond to here. So this would be 7, 8, or 9, and this would be 7, 8, or 9. However, if this is not 7, 8, or 9, that means this has to be 7, 8, or 9, which means these can't be 7, 8, or 9. Again, these can't be 7, 8, or 9, and this can't be 7, 8, or 9. So therefore, this is 7, 8, or 9. Therefore, this is always 7, 8, or 9. And then both of these would be 7, 8, or 9. So it would have to be 7, 8, and 9 here. So either the 7, 8, or 9 is here, which makes the 7, 8, 9 here, or this is 7, 8, or 9, which makes that 7, 8, or 9. Right? So one of these is always a 7, 8, or 9, and then the opposite one is always a 7, 8, or 9, which means in the columns, the rest of the columns cannot contain a 7, 8, or 9, because either this is a 7, 8, or 9, and that's not, or this is a 7, 8, or 9, and this is not. But we know there's two 7, 8, or 9s here. So either way, this can never be a 7, 8, or a 9. So this is 1 through 6. This is also 1 through 6. Same thing here. This is 1 through 6. And this is also 1 through 6. So either one of these is 7, 8, or 9. In fact, actually, yeah, this one has to correspond to a 7, 8, or 9 here, is one of these here. And this one corresponds to one of these two, right? So this is obviously 1 through 6. Okay. So let's start coloring different things. So this one we're going to make blue, and this one we're going to make red. Obviously, the red one has to be one of these two. And the blue one has to be one of these two. Red cannot be here, so this one could be blue. What else could it be? We're gonna make it also possibly a green, right? What about this one? Then this one could be red. It can't be blue. It could also be green, which is the third 7, 8, or 9 here, right? So we know red and blue are here. We know red and blue have to be here. So the green one is either here or here, right? If this is the green, this must be blue and red. But if this is the green, this must be blue and red. So if this is green, obviously red is one of these two. This is blue or red. Sorry, blue and red. Which means blue cannot be here anymore. Blue can't be here. Blue can't be any of these. This must be blue then, if that's the case. So if this is green, this is blue and red. Which means this is red or green, and this is red or green, right? So blue can no longer be here. Blue is one of... this is no longer green. So this could be blue also. Again, if this is green, this is blue and red. This can't be 7, 8, or 9. So this must be blue and red, which means this can't be red. So therefore, this would be red. This would be red. This would be green or red. Therefore, green would be one of these. Therefore, one of these is blue, and one of these is the other green or red, right? This is not green. Therefore, this is blue or green, and this would be blue or green. We have blue or green, and red. Therefore, this could not be 7, 8, or 9. So it would be 4, 5, or 6. And therefore, this would have to be the other red or green. This would be blue or green. This would be blue or green. Right? So then blue or red would be here. This could be any combination of blue, red, or green. So that's how this would work out. Okay. Now say this was green. If this is green, this is blue or red. Therefore, this would be blue or red, which means this has to be red. And this would be blue or green. And this would be blue or green, obviously. So therefore, this would be green, this would be blue. This would be red or green. This would be red or green. This would be green. This would be blue or red. So red would have to be here. This would be red. This would be blue or green. This would be blue or green. This would be blue. This would be green. So this would be blue and red. I don't think this is getting us very much. Okay, what if this is 4 and 6? Does that work? If this is 4 and 6, that forces this to be 5, 7, 9, which forces this to be 8. So say this was 4 and 6, right? Then this becomes 5, 7, 9. This has to be an 8 then, because 4, 5, 6, 7, and 9 are all taken, so therefore this leaves 8 here, which makes this a 5. So this can't be 5 anymore. This can't be 5 or 8. This can't be 5 and 7 here. This can't be 5 and 6. So this can't be, this is 8, which forces this to be 7 or 9, and this to be 7 or 9. These can't be 5, obviously. These can't be 5. No 4 and 6. Oops. No 4 and 6, no 4 and 6, no 4. No 4 and 6, no 4 and 6, no 4. Ah, so we have a 1, 2, 3, 5 triplet here. Ah, there we go. Quadruplet, sorry. 1, 2, 3, 5 quadruplet here. Therefore, the rest of the column cannot contain a 1, 2, 3, or 5. Therefore, this can't be 3 or 5. This can't be 3, 1, 2, 3, 5. This can't be 1, 2, 3, 5. And it can't be 4, 6. So this would have to be 7, 8, or 9. But that's not possible because we already have all the 4 through 9 in box 6. So this is not possible. So this cannot be 4 through 6, 4 and 6 here. Okay, well that helps there. So we know one of these is 1, 2, 3 with 7, 8, or 9. So one of 7, 8, or 9 is here. again, so if this is 7, 8, or 9, that means this is 7, 8, or 9, this is 7, 8, or 9, this is 7, 8, or 9. And if this is 7, 8, or 9, again, so if this is 7, 8, or 9, so say this was the green one, right? This is now red and blue. Where's the red? Red has to be here, so this is red. This is red and blue. This has to be green, then. The green 7, 8, or 9 has to be here. Oh, in addition, right. So we know there are 2 from 7, 8, and 9 here because of the way that 21, 3 cage that adds up to 21 works. This must contain 7, 8, or 9. Therefore, this cannot be 7, 8, or 9 because 3 out of the 7, 8, or 9s are already taken in box 6. So therefore, 7, 8, or 9 cannot be here. So this can't be 4, 5, and 6, which makes this 7, 8, or 9. Interestingly enough. So the rest of the column cannot contain 7, 8, or 9 because we have a 7, 8, and 9 triplet in column 6. I don't know if that helps much, though. So if this is green, then this must be blue. These can't be 7, 8, or 9. Obviously, these can't be 7, 8, or 9. So this is 7, 8, 9, 7, 8, 9, 7, 8, 9. This has to be red and blue, which means this has to be red. So this is green or blue. And this is green or blue. This has to be green. This has to be red and blue. So blue is one of these two, one of these three. It has to be here. So this is blue. Therefore, these must be red or green because it has no other place to go. Red cannot be here. What else do we know? Unfortunately, I don't think this takes us anywhere that much. We know 2 from 7, 8, and 9 is here. 1 has to be from here. Right? But we don't know which one it can be. Right? We know 1 is obviously here. So this is 2. This would be 1. So the red one would have to be one of these two. Ah, this is not... Okay, so therefore, this could be blue, green, blue or green. This would be the 7, 8, and 9. These would be blue, green, or red. Right? So we have the same problem that we had previously, right? Huh. But in this case, we don't have any restrictions that lead to one of these being blue or red or green, right? The other 7, 8, or 9, essentially. We know the rest of this is 1 through 6. Oh, okay, actually, maybe that will help something. So we know the rest of this is 1 through 6 because we have 2 from 7, 8, 9 here, 1 from 7, 8, 9 here. Oh, okay. That does help us. We know where are the 7, 8, and 9s in column 9. Can't be these two. Can't be this one. Can't be these two. So this one has to be a 7, 8, or 9. Same here. This has to be a 7, 8, or 9 because there's no other place for it in column 9. We know one of these two is a 7, 8, or 9, but we don't know which one. So that's not that helpful. One of these three has to be a 7, 8, or 9. One of these three has to be a 7, 8, or 9. We're just not sure which. We do know one of them has to be here. So one of these two columns contains one 7, 8, or 9. But we're not sure about where the other one is, right? It could be any of these four. Uh-huh. One of these two must be 7, 8, or 9, right? It cannot be neither, right? So, is that the case? We know one is 7, 8, 9 here. There's another one here. Can they both not be 7, 8, or 9 is the question, right? If this is not 7, 8, or 9, that means this must be 7, 8, 9, and that must be 7, 8, or 9. Which means none of these, there's two 7, 8, and 9s here. This can't be 7, 8, or 9. Where are the 7, 8, and 9s in box 1? It has to be here and here. Which means, okay, so if this is not 7, 8, or 9, that forces this to be the 7, 8, or 9. So therefore, this can never be 7, 8, or 9. So this is 1 through 6 also. So one of these two is... this one we don't... I think, do both of them have to be? Yes, because there's at most one 7, 8, or 9 here, and there has to be a 7, 8, or 9 here. Because of what the rest of the column is. So this must also be 7, 8, or 9. And this is 7, 8, or 9. Okay. So then one of these two is, we're not sure, and one of these two is. And then it's the opposite, right? So either this is 7, 8, and 9, that's 7, 8, and 9, or this is 7, 8, and 9, that's 7, 8, or 9. Okay. I don't know if I would consider this easy. This is, yeah. A lot of trial and error, it feels like. So we know these are 1 through 6, and this is 1 through 6. If this is 4 and 6, that's interesting. Then this is 3 or 9 or 5 and 7. Where would the 7, 8, and 9s be? It would have to be here and here, if that's the case. So say this was 4 and 6, right? Then obviously these couldn't be 4 and 6. This couldn't be 4 and 6. You'd have 1, 2, 3, 5. One of these is 3 or 5. So therefore, this would have to be 7, 8, 9, and this would be 7, 8, 9. This would have to be 2 out of 7, 8, or 9, which is fine. Yeah, this all seems kosher, right? So this would mean, I don't know, we'd make this green. This, well, the problem is, yeah, that doesn't really help us much, though. Hmm. Mm. So if this is 7, 8, or 9, this has to be 5, 6, 5, 6. Which seems reasonable. So then the 7, 8, or 9 has to be one of these two. We know 2 out of 3 have to be here. We know 1 has to be one of these two. Well, let's say this was not 5 and 6. That would force this to be 7, 8, and 9, which would mean this cannot be 7, 8, and 9, which means this would be the 7, 8, 9, 8, 7, 8, 9, 7, 8, 9 triplet in box 4, or sorry, box 5. Does that tell us anything? I'm not really sure it does, right? We still don't really have very much information about the rest of the puzzle. Hmm. One of these is 7, 8, or 9. One of these is 7, 8, or 9. So blue is always either here or here. Red is always either here or here, right? We don't have very much other information here, right? Oh, one interesting thing that I thought, well, not completely, never mind. One thing that's interesting though is if this is 2, this have to obviously be 1, which makes this a 2, 3, 2, 3 pair. Right? So this is 2, 3, 2, 3. That's 7, 8, 7, 8. So if that's the case, this cannot be 1, 2, or 3. So this becomes 4, 5, and 6. This cannot be 1, 2, or 3, so it's 4, 5. So this has to be 5 or 6. This becomes 7, 8, 7, 8. So we have 4, 5, 6, and 9. This would be 4, 5, 6, and 9. What does that mean, though? This is 2 and 3, 2 and 3. Therefore, there must be a 2 in one of these spots. Oh. Oh. That's interesting, right? This is 2 and 3 and 2 and 3. Therefore, this can't be 2 or 3, right? So it has to be 6, 7, 8, 9. This must be a 2, which means 3 is here, 3 is here, and 3 must be here then. So this can't be 1 or 2. This can't be 1 or 2. This can't be 1 or 2. This can't be 2. So this must be 1, 3, 1, 3 pair. So this can't be 1 or 3. The 4 must be one of these. Therefore, these can't be 4. This can't be 4. None of these can be 4. So 4 must be here, which means this can't be 4. So this is 5, 6. This cannot be 5 or 6, so that can't be 5 or 6. So this can't be 2, this can't be 9. This is 7 or 8. We have a 7, 8, 9, 7, 8, 9, 7, 8, 9 triplet in column 5. So this can't be 7, 8, and 9, which makes this not 3, 4, 5. Okay. That seems fine. This can't be 2 anymore. So this can't be 2. These can't be 2. This can't be 1. Can't be 1. So 2 cannot be here. 2 cannot be here. Interesting. So then 2 would have to be one of these. Obviously, this couldn't be 1. This couldn't be 1. This couldn't be 9. This could be 9. So far, this is working okay. This can't be 3 anymore, so this must be 4, which makes that 7. So this can't be 7, which means this can't be 6 with it. This can't be 1 or 9. So this has to be 7 or 8, which means this must contain a 9. So this can't be the 9 then, which would force this to be the 9. So far, it's all okay. This is 1, 5, or 6. This is 1, 5, or 6. This can't be 4, so this can't be 8. This can't be 5, so this can't be 7. So this would be 3 and 9, which would force this to be 8 and 5. So this can no longer be 5. This has to have a 9. So this has to be then 4, 8, and 9. This can't be 8. This can't be 2 and 8. This is 3 and 7. So this can't be 7. This can't be 3, 4, 5, or 1. This can't be 3, 4, 5. This can't be 3, 4, 5. So it's 1, 2, 6. No 3, no 3, no 7. This can't be 7. This can't be 8. So this can't be 2. This is very convoluted. I don't know. I don't like this really very much. This can't be 5. This can't be 4. This can't be 3. This can't be 7. So this would be the green, essentially. Which means this is 6, 7, and 8. So this can't be 6 or... can't be 6. Can't be 1. Can't be 3 and 7. So this becomes 2, 8, 2, 6, or... This can't be 6. So this can't be 6, so this is 5, which forces this to be 4. That's fine. Therefore, this can't be 5. We have a 4, 5, 6 triplet here. Therefore, this must be the 5, which makes this 6. This has to be 3 then, so that can't be 3. Interesting. Okay. So, in a convoluted way, we showed them that this can't be... So far, all of that works fine. So we showed, though, if that was 1 and 2... We showed that if this is 1 and 2, this can never be 3. in a long, really convoluted way. I don't think I like that, but right? Because if this is 2, this is 1. This has to be 2, 3, 2, 3, right? Which forces this to be 7, 8, 7, 8. This is 2 and 1 again. This can't be 1, 2, or 3. This has to be 4, 5, which makes this 5 or 6. It's so convoluted. I don't know. So this is 4, 5, 6, or 9. This is 4, 5, 6, or 9. This can no longer be 9 here, so this has to be a 9 here. Hmm. I might be just missing something here. But anyways, yeah, we've shown that this can never be 3. Uh, yeah, so that's only the case because this is 1, which forces this not to be 9, which means this has to be 9, right? So if this is 2 and 1, yeah, therefore none of these can be 9. Therefore that can't be 9. So therefore that would have to be the 9 then. Because the 9 would have to be one of those 3. Yeah. Are there any other ones that force this? I don't know. One interesting thing though is that this 2 and 1 eliminates the possibility for this to be 2 and 1. That was very interesting to me. Oh, actually, I guess that really does make sense, right? If this is 2, that means 2 can never be here. Well, no, 2 could be here. Hold up. How did we eliminate that from being 2 and 1? If this is 2 and this is 1, not 0, if this is 1. Oh, because the 2 has to be there, which eliminates 2 being here. Obviously, this can't be 2. This can't be 2. I think it just eliminated the possibility for it to be 2 and 1, right? Hmm. Yeah, we don't have that many restrictions there, unfortunately. Hmm. The only reason is because these two have to be 1, 2, and 3. Hmm. Which forces that to be the 4, 5, which forces that to be 5 or 6. Uh, Hmm. Okay. Well, what happens if we make this 1 and 9, right? Then this becomes 7 or 8. This is 7 or 8. This has to be 6, 7, or 8. So this can't be 6, which means this can't be 7. There's no 1 here. There's no 1 here, which means this can't be 2, and this can't be 2. So far, everything's kosher. This obviously can't be 1 or 6. This can't be 1 or 6, and this can't be 1 or 6. Hmm. Seems fine. This can't be 6, 7, or 8. This can't be 6, 7, or 8. Oh, that's interesting. So therefore, this can't be 5 anymore, and this can't be 5. Because these can't be 6, 7, or 8. Huh. Hmm. This doesn't really seem to tell us much. This is 1 through 5 or 9. This is 1 through 5 or 9. Hmm. Yeah, I would not consider this easy. This is a lot of stuff you have to go through just to, like, try to eliminate possibilities here. Unless I'm missing something obvious. I don't think I am, though. Um, hmm. Yeah, this doesn't seem to be going anywhere. We're not restricting anything here. Um, hmm. Oh, that is interesting, actually. Okay. What happens if... Well, it's something similar here, right? If this is 2 and 1, then this has to be 2, which forces one of these three to be 2, so therefore that must be 2, which means this cannot be 2 and 1. This obviously couldn't be 2 and 1 because of this 2, so this can't be 2 or 1 also. If either of these is 1 or 2, the opposite side cannot be 2, right? The opposite side still couldn't be 1 at the bulb. but you can never have a 2 here, and you can never have a 2 here. Which would mean a 2 has to be here. 2 has to be one of these 3, or it'd be one of these 2. And then 2 would have to be here, right? I guess it could be here too. Yeah, 2 would be one of these 3. And then 2 would be one of these 3. What does that tell us? I'm not really sure. Hmm. Hmm. I don't understand how people consider this easy. I might just be missing something very simple. Um, hmm. Okay, so what are the possibilities for this not to be blue? If this is not blue, that means blue can never be anywhere here. So this would have to be the blue then, if that's the case. If this is the blue, this would not be red. So this would have to be green, which would make this red, which would make this green. So then this would be green or red. This would have to be red. This is green or red, so this can't be green. Therefore, this would be green. This would have to be green, and therefore this would have to be green. Therefore, this is red and blue, which means this has to be red, and then this would have to be blue, which makes this blue. So far that all looks fine. Um, hmm. This would then be red and green, which is fine. Hmm. Yeah, this all looks fine. Um, hmm. Yeah, that seems fine. Hmm. Probably is going to be the same this way if I tried this to be red, right? If this is... Okay. Well, actually, that does tell us information. So one thing we do know then... Okay, so either this is blue or... Either this is green, and this was forced to be blue-red, which forces this to be blue, and this is red and green, red and green. Or this has to be blue. If this is blue, this becomes red and green. Right, so okay, let's go through that. This is blue, which forces this to be green. which means this is red, right? Because this can't be blue here, and it can't be green here, or red here. So this has to be the green, which means this is red and blue, which means this has to be green. So either this is green or it's blue, right? So this is blue or it's green, right? Similarly, if this is red, this would have to be green, which would force this to be blue, which would make this green. And then this would be the green, obviously. This would be blue. This would be green, so this is blue and red, which means this has to be the red. So therefore, this is red, right? So that's fine. Which would mean this is green. And this has to be blue and green, which forces this to be blue. Oh, wait. That's interesting. Okay. So say this was the green, all right? If this is green, that means this is blue and red, which means this has to be blue, right? Which means this is red. If this is not green, that means this is green. This could be blue or green. But if this is blue, this can't be green. So this has to be blue and green. And this is blue and green. And this has to be red. That doesn't... So again, if this is green, this has to be blue and red, which forces that to be blue, which means this has to be red. So that's all we know there. If this is not green, that means this is green. This has to be blue and red, which forces this to be red. Which means this is blue and green, and this is blue and green. Now, these become blue, green, and red. So this is blue or green, obviously, and this is blue or green. This could actually still be green. No, that doesn't help. This has to be blue. If that's the case, if this is green and red. So obviously blue would have to be one of these two. That's not saying very much. So obviously if this is green, this becomes red. This has to be blue because this is blue and red. And this is green. This would be green and red and green and red. If this is green, this is blue and red, which forces this to be red. So this can no longer be red, but this is not the 8 or 9, so this could be blue, green, or red. Assume this was blue. Then if this is blue, this would have to be green, and this would be blue, right? Because we know this can no longer be the 7, 8, and 9 in that instance. So this could be green or red if in that case, right? And this could be green or red, and this could be green or red. Blue would still have to be here, right? If this is blue, that means this can't be blue, this can't be blue. The blue would have to go one of those three. This would be blue. This would have to be the red then, if that's the case. This would be green, which would force this to be blue. Right? So then this would not be blue in that instance. This would not be green. This would be blue. So then this would be blue. This would not be red, so that would be red. But the problem is it still could have been red and green in the previous one. So then this is green, which forces this to be again, this is green, which forces this to be red and green. That's fine. So all of this is kosher. I don't, yeah, I don't understand why people are saying this is easy per se. There's a lot of stuff you have to go through to get to this stage even. And this is still not breaking apart. Like the break-in for this part is seems pretty complex. Hmm. What about the 1, 2, 3, 7, 8, and 9 combo? Right. This is a 1, 2, 3, 7, 8, 9. This is 1, 2, 3, 7, 8, 9. This is 1, 2, 3, 7, 8, 9. This is 1, 2, 3, 7, 8, 9. This one we don't know. So obviously these are different. This could be blue, red, or green. So this is the corresponding 1, 2, 3 red, and this is the corresponding 1, 2, 3 blue. So neither of them can be here. One of them could be any of these. This can't be 3, right? We tried, yeah, it cannot be 3. Oops, this is 6. I missed a 6 here. This can't be 3. So this is the corresponding 1, 2, 3 red, and this is the corresponding 1, 2, 3 blue. Neither of which can be here. Any of them could be here. So this could still be the red one, because this could be the red 7, 8, 9, and the red 1, 2, or 3. The question is, can this be the red ever? Is the question, right? If this is red and this is red, that means this would have to be red. So then this would be blue and green. One of these would be blue or green, obviously. So this can't be blue, and it can't be red then. Then this would have to be green, which makes this the blue, which makes this green. So this is blue or green, which forces this to be the blue. This is green, so therefore this would have to be green. Which would mean green is here. That's fine. This can't be green. This can't be green. This can't be blue, green, or red. So this is blue or red, this is blue or red, which forces to be red and this to be blue, right? Which means this is red. Whoops. This is red. This is red or blue. So far it's all fine, right? Mm. Blue can't be here, 1, 2, or 3. Red can't be here or here. So the red 1, 2, or 3 is here. So far that looks fine. The red 1, 2, or 3 has to be one of those 3. And it has to be one of those 3. Mm. Mm. Uh, can this be 1, 2, or 3? If this is 2 and 1, then this becomes 2, 3, 2, 3. Which means this cannot be 1. This would have to be 2 because this is 2. That forces this not to be 2 and this not to be 2, which means this is the only place for 2. This can't be 1, 2, or 3. 3 has to be one of these 3. But 3 could be one of these 2. So why couldn't this be 3? Was the question, right? In the opposite way, right? If this was 2 and 1, then this becomes 2, 3, 2, 3. Therefore, this can't be 2. Therefore, this is 2. Right, 3 can no longer be here, right? Along here. So this is 3, which means one of these is 3. This can't be, this is 4 or 5. So maybe, yeah, it might be similar there then. So if this is 2, this is 1, which makes this 2, 3, and 2, 3, which makes this 4 and 5. So this becomes 5 and 6, which means this can't be 4 or 5. So therefore, this is a 2. This has to be a 1, 3, 1, 3 pair because 1 can't be here. 3 has to be one of these 2. This can't be 2 or 3. This can't be 8 or 9. This can't be 3. So 3 has to be one of these 2. Therefore, it must be 1, 3, 1 and 3 pair. So this can't be 1 or 3. This can't be 1 or 3. This can't obviously can't be a 2. This can't be 1 or 2. This still could be a 3 here. Why can't that be a 3? Hmm. Did I mess that one up? Um, so say this was 2 and this was 1, right? Then this becomes 2, 3. I think it was because this was not 9. Right, so this couldn't be 9. Therefore, the 9 has to be here, which means this can't be 9. And this is 7, 8, 7, 8. Therefore, this would be 9, which means this is 6, 7, 8. Because it can't have a 9. Therefore, this can't be 2. Well, first of all, this is a 2. This can't be 1, 2, or 3, so this is 4 or 5. This can't be 2, 3, or 4. It can't be 6, so therefore this becomes 5. This is 4. This can't be 2 and 9. This can't be 1 and 2, obviously. This can't be 1, 2, 1, 2. Oh, this can never be 3. So this has to be 1 and 3. So this can't be 4, 5. This can't be 9. This can't be 9. So this has to be 6. Okay. This can't be 3 or 5. This can't be 3 or 5, so it's 4, 6, 4, 6. This has to be a 5 or 6, so this can't be 6, so this is 5, which makes that 6, so this can't be 5, 6, 5, 6. This is 4, 6, 4, 6, 5, so that must be a 3. Oh, that's the reason why. Because that had to be a 3, is the point. Right, but specifically because the 9 was eliminated. That's the reason why. So again, this has to have a 9. It can't be 5 though, so it has to be 4, 8, 9, which forces this to be 3, 7, which means this can't be 7. This can't be 4, 5, or 6. This is 7. This can't be 4, which means this can't be 9. This all seems kosher. This is 4. This is 7, which makes this 8, which makes that 5. So that seems all good. This is 2 and 6. This is 1, 2, and 6. This is 1, 2, and 6. This can't be 8. This can't be 7, so this must be 3, which makes this 7. So these can't be 7, which makes this 7, which makes this 3. Oh, we have a contradiction. Man, that's a long way to get that contradiction. I don't really... So this can't be 7, so it can't be 5 and 7. It can't be 8 because of the 8 here, so this can't be 4 and 8. Therefore, this would have to be 3 and 9, but this has to be 7 because this is 6, 7, 8. That's a really long contradiction. I don't know if I'd like that as a... Anyways, that shows this can't be 2 and 1. So this can't be 2. That's all that's shown. So that just shows that this can't be 2. That's all we prove there. Okay, so one thing that's interesting, though, is if this is a 1, we have kind of a similar thing here. This can't be 1, 9, then, which means the 9 has to be here. So this has to be 4, 8, 9, or 5, 7, 9, right? Which means this can never be 9, and this can't be 9 and 1, and this can't be 1 and 9. Therefore, this must be 9, which forces this to be 6, 7, 8, right? So this becomes 6, 7, 8. This obviously is 2, 3, or 4. So this can't be, okay, this can't be 1, 2, or 3. This can't be 2, 3, or 4 because of that, and it can't be 6. So this forces this to be 5, and that forces that to be 4. This can't be 1, 2, 3, or 4. This is 5 or 6. This is 5 or 6, so therefore this can't be 5 or 6. So this is 5 or 6. This obviously, none of these could be 1. These can't be 5. This can't be 5 or 4. Can't be 4 or 5. This can't be 5 or 4. The 9 is here, so this becomes... this has to be something, and this has to be something, which means this is... So this is not... This has to be 7, 8, or 9. This is 7, 8, or 9, which means this has to be a 6. Obviously, this can't be 6. This can't be 6. This has to be a 7, 8, or 9. This cannot be a 7, 8, or 9. So this can't be 6. This can't be 6 here. Therefore, none of these can be 6. This can't be 9. One, two, three, 1, 2, 3, 1, 2, 3. Obviously, this can't be 1, so this can't be 1. So the 1, this can't be 2 or 3, so this is 4, which makes this 7. So this can no longer be 5, 7 here. This can't be 7, 6. So this is 4 or 5, and this is 4 or 5. Which means you cannot have a 4, 5 in box 6 anymore. So this is 4, 5. This can't be 1. These can't be 1. Which means this can't be 2 specifically, and this can't be 5. So where is the 5 then in column 9? This can't be 5. So and this can't be 5, and that can't be 5 since this is a 4, 5 pair. So this one has to be the 5, which means this can't be 5. And this can't be 4. This can't be 5. These can't be 5. These can't be 5. So where's a 5 in? So this can't be 6 anymore. So this becomes 1, 2, 3, 4 also. So therefore we have a 1, 2, 3, 4 quad in box 1. Because this can't be 5 anymore. It can't be 6. So I think this is for any one here. This is really convoluted just to get to this. And then this would have to be a 5 because of the 1, 2, 3, 4 quadruple in box 1. But the problem is this is now less than this. So that's contradicted. So now we've shown 1 cannot be in the bottom right corner. But that's really convoluted to get there. I don't think this. How is this easy? I don't know. Maybe I'm missing something really obvious. So this cannot be 1. Still, this I'm starting to see a pattern, I think, actually. So what happens if this is 2 and 3 then, if that's the same thing? Obviously, so if this is 2, the same thing is here, right? You have a 7, 9, 7, 9 pair, right? But this cannot be 2 and 8. So the 8 has to be here, which means the 8 cannot be here, which means this has to be an 8 then, if that's the case, right? So this is 8, this is 8. This can't be 2 and 3, this can't be 1 or 3. Therefore, this can't be 1, 2, or 3. Well, but this is not quite the same, right? So this is can't be 2, 3, 4. So this is 5 or 6. This can't be 8. So this is 7, 9, 7, 9. This can't be 1, 2, or 3. It's 4, 5, or 6. This is 4, 5, or 6. This is a 7, 8, 7, 9, 7, 9 pair. So this has to be 7, 8, 9, which means this can't be 7, 8, 9. So therefore, this has to be the 7, 8, or 9. And this is 7, 8, or 9 also. So we have 7, 8, 9, 7, 8, 9. This can't be 2 and 8. Therefore, this has to be either 4, 8, 9 or 6, 7, 8. This cannot be 4, 8, 9 or 6, 7, 8. So it has to be 5, 7, 9. So obviously this can't be 5, which forces this to be 1 or 3. This can't be 3. This can't be 8. This can't be 5 anymore, so this is 6. Which is a contradiction. Which means this can't be, this has to be greater than 6, but the problem is we already have 3 greater than 6, and those are the only 3 digits that are left, which eliminates 7, 8, and 9, which means this is smaller. So we've shown that 2 does not work. Interesting. This, I don't know, though. That seems... This can't be 2, then, which means this can't be 3, which means this can't be 4. So, what again, similarly, if this is 3, that means this can't... That's 3 in the corner, which we celebrate, but I don't feel like celebrating. which means the 7 has to be here, which means this is either 5, 7, 9, or it's 6, 7, 8, right? So it's 5, 7, 9, or 6, 7, 8. So this cannot be 7 either way. So therefore, this can't be 1, 2, or 3. This can't be 2, 3, or 4. This has to be a 7 because this can never be a 7 then. So this has to be 7, which means this cannot be 6, 7, 8, or 5, 7, 9. So this is 4, 8, 9. Which doesn't actually show anything now. So this has to be greater than 5 or 6. This can't be 7. We have a 7 here and an 8 and 9 pair here. Therefore, this cannot be 7, 8, or 9. It has to be greater than 5 at least. So this must be 6, which makes this a 5, which makes this a 4. So this becomes 1, 2, and 3, 1, 2, and 3, 1, 2, and 3. So it can't be 1, 2, 3, 4. So this is 5 or 6. This can't be 6. So this is 6, which means this has to be a 6 here. This can't be 5. Can't be 3, obviously. So the 3 has to be one of these two. So this can't be 3. These can't be 5. One of these is 4. This can't be 3 or 4. This can't be 6. So this has to be 5, which means this can't be 5. Therefore, this would be 7, 8, and 9. This is 7, 8, or 9. We have a 1, 2, 4, 6 triplet here. That's fine. This can't be 5 anymore. So this has to be 6, 7, and 8, which makes this 1 and 9. Which means this can't be 9. This can't be 6 anymore, so this is 4. This can't be 4. This can't be 4. This can't be 4. This can't be 6. This can't be 1. So this can't be 9. This can't be 6, 7, or 8. This has to be the 9, which means this is 8, which means this is 6. So that's okay. That means this is 8, this is 9, this is 1, this is 2, this is 8. So far, this is all okay. This is 7, this is 9. So this can't be 7, this is 8. This can't be 7 or 9, so this... Oh, sorry, it can't be 8 or 9, so this is 7. That's all okay. This can't be 8. This has to be 7, which forces this to be 9. So far, this is all okay. These can't be 4 or 5. It can't be 6, so this has to have a 3 here. So this is a 1, 2, 3 triplet. And then we have a contradiction because this can't be 1, 2, or 3. It's 4, 5, which is greater than 2 or 3. I don't know how you're supposed to show this in an easy way. This doesn't seem easy at all. Yeah. So we've shown now. These are, yeah. So this cannot be 3 then. So this has to be 4 or 5, which means this can't be 5 or 6, which means this is 6, 7, 8, or 9. Right? Because the whole point is that basically the 1, 2, or 3 means the thing that's corresponding to the 1, 2, or 3 cannot be here, obviously, because it can't be... the 7, 8, or 9 has to be in this one, right? If this is the same one, the 7, 8, or not, the corresponding 7, 8, or 9 has to be either here or here, right? This forces this not to have this corresponding 7, 8, or 9. So the corresponding 7, 8, or 9 has to be here, which forces this to be 7, 8, or 9. And through various different methods, you can figure out that that eliminates all possibilities. So that restricts everything. But the thing is, this is not easy. I don't understand why people think this is easy, per se. Anyways, this is 4, 5. This is 5 or 6. This is 6, 7, 8, and 9. Um... Hmm. Um, so then what happens if this is green? If this is the other 7, 8, or 9. If this is the other 7, 8, or 9, obviously this can't be, right? So this must be 6, which forces this to be 5, which forces this to be 4. Therefore, the other green would have to be here, right? This could not be 4. This cannot be 5. This can't be 5. This can't be 5. This would have to be 7, 8, or 9. This can't be 6. So 6 is one of these three. This would have to be 6, which means this can't be 5 or 6. So this is 7, 8, or 9, which means this can't be 7, 8, or 9, which means this can't be 3, 4, 5. This can no longer be 6. So this is 4, 5 with then 8 or 9. No 4, 5, or 6 here. This can't be 5 anymore. So this can't be 5, 7, 9. So it's either... So the 5 would have to be one of these two, which means this cannot be 5, which means one of these two is 5. This can't be 5 anymore. There's no 4. There's no 4 here. This is not 4 or 6. So 4 or 6 has to be one of these two, and then one of these two is 4 or 6. This has to be the 7, 8, 9. This cannot be 7, 8, or 9, because we have a 7, 8, 9 triplet here. This is not green, so this is 7, 8, and 9, which means this can't be 7, 8, or 9. So far, this is looking fine. Hmm. So then green would have to be one of these two. This is blue and red, so this would have to be red. One of these is blue or green. This has to be what? Okay, so it's 4, 8, and 9, or 6, 7, and 8. So this cannot be 2 or 8. Okay, so therefore this would then be 7 or 9, which means 2 would have to be one of these two. So this could not be 2. This would be 1, 3, or 5. Hmm. So far it's looking fine. This can't be 6. This can't be 6. Green. This is blue. So green and red are here. Green and red are here. This is also green or red. This is green or blue. And this is green or blue. Because this cannot be 6 because of this now. This has to be 2 through 5. This is 1, 2, 3, 4, or 6. Hmm. Yeah, this is so complex. I don't... Uh, this cannot be 4 or 5. This cannot be 4 or 5. None of these could be 4 or 5. These can't be 4 or 5. So the 4 or 5 has to be here, which means these cannot be 4 or 5. So this has to be 6, 7, or 8, which means this is, oops, this is 1 and 9. So this is 6, 7, 8. The 4, 5 has to be here. This is now 1. So this cannot be 4, 5, or 6. This can't be 1 either. So this can't be 1. This can't be 1. We have a 2, 3, 2, 3 pair. And 1 and 9. Okay, so we've just shown then. Right. I don't think this is easy at all. This is challenging, I think. I think this is definitely challenging. It's not hard, but going through it is kind of, well, it's kind of a pain, basically. This is now 1, which means this can't be 1, this can't be 1, this can't be 4, 5, and 6, so this has to be 2 or 3. So we have a 2, 3, 2, 3 pair now in column 9, which forces no other 2 or 3 in that column. 1 and 9 is eliminated. Therefore, this can't be 2 or 3 or 1, so this is 5. And this has to be 6 then because of the elimination of the 2, 3, and the 5. But then this is now less than this. So we've shown this square cannot be green because that was all predicated on that assumption. So therefore, this is not the other 7, 8, or 9. God, that's convoluted to just prove that. That's I don't know if I like this. Anyways, that shows this cannot be green. So this has to be a 7, 8, or 9. And this one has to be the green. So this is green. This is the other 7, 8, or 9, which means this is blue and red. The blue and red 7, 8, or 9. This has to be red. So therefore, this is blue. This cannot be 7, 8, or 9 because it has 3, 7, 8, or 9s in column 2. Therefore, the 7, 8, 9 in box 1 has to be here. So this is green or red. Green or red. And this is green or red. We're not sure which. Therefore, this cannot be 7, 8, or 9, which means this can't be 6, which means this can't be 5. So this is the 7, 8, or 9. We don't know which one it is. This is blue or green. This is blue or green. This is 1 through 6. This is 1 through 6. So the green has to be one of these 3. We're not sure which, though. Not that one. It has to be one of these 3. This is blue or green. This is obviously blue or green. This could be blue, green, or red. And this is blue, green, or red. Oh, it can't be blue. This is green or red. So this is green or red. This is green or red. This could be blue, green, or red, unfortunately. So this cannot be 7, 8, or 9 either. So this is 3 through 6, which means this can't be 6 and this can't be 5. Hmm. let's say this was 6. If this is 6, that forces this to be 5 and 4, which makes this 6 and this 5, which makes that 6. So this can't be 5 or 6. This can't be 5 or 6. We have a 7, 8, and 9 triplet in column 4, so that can't be 7, 8, or 9. This is not 4, 3, 4, 5. This all seems kosher, so then this could not be 4, 5, or 6. These can't be 5 or 6. This can't be 4, 5, or 6. 1, 2, or 3, 1, 2, or 3, 1, 2, or 3. This cannot be 5. So therefore, it's 4, 8, 9, or 6, 7, 8. So therefore, this can't be 8. This would be 7 or 9. This can't be 6 anymore. So it's either 4, 8, 9 or 5, 7, 9. 4, 8, 9 or 5, 7, 9. So this can't be 9, which means this can't be 9 either. This has to be 2, 7, or 8 with it. This can't be 6. Since this can't be 6, this can't be 4 specifically. This seems okay. This can't be 6. None of these could be 5. These can't be 4. This all seems fine. This can't be 6 anymore. 6 is one of those two. 6 could be any of these 4. This can't be 6. That's 4, 5. This can't be 5. This can't be 5. This is the green 1, 2, or 3. This is the red. This is the blue. Which doesn't really tell us much. The 4 has to be one of these two, so this cannot be 4. So one of the 4 5s has to be here. Therefore, this can't be 5. Oh, well, it could be 5. This is really what people consider easy? I don't know. I must be missing something really obvious. I'm not sure what, though. Either that or people, I don't even know. Again, like, this is why you always take the easiness with a grain of salt, because then these things can get very convoluted and stuff. Oh yeah, because I tried having a 6 here, which is the only other possibility. So we tried having a 6 here. That didn't work because this would be 5, that would be 4. This could no longer be 5. How was that? That was very convoluted. I think it was somewhere up here which showed that it couldn't that there was a contradiction. We know 7 actually is up here. This can't be 7. So therefore one of these is 7, which means this can't be 7. So this is 8 or 9. 7's one of these two. One of these 4 is 4, 5, or 6. But does that tell us anything? Maybe? I don't know. Say this is 1, 2, or 3, right? Then this is 4, 5, or 6. This becomes 4, 5, or 6. This is 4, 5, or 6. So this becomes 1, 2, 3, 1, 2, 3, 1, 2, 3. This becomes 4, 5, or 6. So again, if this is 1, 2, or 3, therefore this becomes 4, 5, or 6. This is 4, 5, or 6. This one of these is 4, 5, or 6. So this can't be 4, 5, or 6. This can't be 4, 5, or 6. So it's 1, 2, 3, 1, 2, 3, which forces this to be 1 or 2. We know one of these is 1, 2, or 3 because this is a 4, 5, 6 triplet. So this is 1, 2, 3, 1, 2, 3, 1, 2, 3. This is the green 1, 2, or 3. This is blue. This is red. Obviously one of these is 1, 2, or 3. One of these is 1, 2, or 3. One of these is 1, 2, or 3. So the 4 has to be one of these 3. No, we don't know. Yes, because this is 4, so this can't be 4. This cannot be 4 then, which means this can't be 5 or 6. This can't be 5 or 6. This can't be 7, 8, or 9. Therefore, this can't be 3, 4, or 5 because of the 7, 8, 9 triplet here. And this, so therefore, this can't be 7, 8, or 9. This has to be 3 because this can be only 1, 2 with that. So this is 1, 2, 3, 1, 2, 3. Ah, and that's a contradiction. Okay, so we finally showed then we know what this number is. So by this 1, 2, or 3 force this to be 4, 5, or 6. This is a 4, 5, 6, 4, 5, 6. That's 2 out of 4, 5, or 6. We know this has to be 4, 5, or 6. Therefore, the 4, 5, or 6 cannot be in the rest of the column. So this becomes 1, 2, 3, 2, 3. Because this is less than this has to be 1 or 2. So we have a 1, 2, 3 triplet in box 3. But the problem is we have a fourth one here. So therefore you have 4 cells which must contain 1, 2, and 3, which are only 3 digits. So therefore that doesn't work. So we've proven the contradiction now. And because of that, now we know the path that we were going down earlier, which was this is 4, this is 5, and this is 6, has to be the case. Because we've shown that if this is 1, 2, or 3, that fails in a lot of ways here. So this becomes 4, this is 5, and this is 6. So we know that for certain. So this can't be 4, 5, or 6. This can't be 4, 5, or 6. This can't be 4, 5, or 6. None of these can be 6, which means this can't be 4. This can't be 4. This can't be 6. These can't be 5, and this can't be 5. So therefore, this has to be 4, 8, 9, or 6, 7, 8, which again shows this is 7 or 9. So the green has to be 7 or 9, which means this is 7 or 9. Okay. Wow. I don't... So this can't be 5 anymore, so therefore this is 6. This can't be 4, so this is 5. So this can't be 4 or 5. This can't be 6. Where is the 6 in rows 9? It can't be here. It can't be here or here. So therefore, this must be a 6, which means this cannot be 5 or 6. So this has to be 7, 8, 9. So we have a 7, 8, and 9 triplet in column 5. So this can't be 7, 8, or 9. This can't be 3, 4, 5. Now we know where all the 7, 8, or 9s are in box 5. Okay. This is 5 and 6. So this cannot be 6. This can't be 6. This can't be 5. There's no 5 here. And there's no 6s here. So 2 of these have to be 4. Right? Because this can't be 4, this can't be 4, this can't be 4. So the 4 in row 8 has to be in box 9. So this can't be 4. This can't be 4. This can no longer be 6, 7, 8. This can't be 6. These can't be 5. So 4 is one of these two. This is 1, 2, or 3. This is the green 1, 2, or 3. We're not sure which one that means. This is the red 1, 2, or 3. This is the blue 1, 2, or 3. The green 1, 2, or 3 cannot be 2 because it has to be with 7 and 9. And we know the 8 is here because it's either 4, 8, 9 or 6, 7, 8. This has to be, cannot be 6, so it can't be 6, 7, 8. So it has to be 4, 8, 9 or 5, 7, 9. So either way, the 9 is here, which means this can't be 9. This can't be 9 then, so this is 2, 3 with 7 or 8. So we know the 9 is here. Let's see. One of these is 4 or 5. If this is not 5, we know. We know one of these two is 7, so this cannot be 7. So this is 8 or 9. The 5 has to be one of these. So this is 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. There is no 6 here. This is 2 or 3 with 7 or 8. This is either red or blue, 1, 2, or 3, and one of the red or blue 1, 2, or 3s has to be here. That doesn't really tell us much. The green could be here or here. We're not sure. 1, 2, or 3. One of them's here. We can only know one of them's here, so one of them has to be here too then. So 2 of them are here. 2 of them are here. We have 1, 2, 3 here. Yeah, this does not seem easy at all. This doesn't help much. This is useful though. So since this can't be 8, one of these is 8, which means one of these has to be 2, which means none of these can be 2. So this can't be 2, which means this can't be 9. Oh, interesting. So either this is 9-3 or this is 9-4. I don't know what that really tells us. Hmm. Okay, so if this is 3 and 8, that eliminates 3, 9, and 4, 8, so this has to be 5, 7. So this would be, in that case, 5 and 7. If this is 4, 7, that eliminates 3. If it's 4, 7, that eliminates 5, 7, and 4, 8, so this has to be 3 and 9. Interesting. Um, hmm. So, again, if this is 3, 8, that makes this 5, 7, so this has to be 9 and 4, if that's the case. This is 9, this is 4. If this is 4, 7, that makes this 3, 9, so this has to be 8 and 5. Okay, so now we know this is 4 or 5, right? So yeah, again, we tried. So the 2 cannot be here. That's actually pretty clever, actually. I like that. But still, this is not easy. If this is 5, if this is 2, this can't be 2 and 9 because there cannot be a 2 here because we know 2 is one of these two because of this forced to be 8. So 2 is one of these two, which means this can't be 2. So this can't be 2, 9. So if we try this as 3, 8, that eliminates 3, 9, and it eliminates 4, 8, so this has to be 5, 7. If this is 4, 7, that eliminates 4, 8, and 5, 7, so this is 3, 9. So if this is 3, 8, that means this is 5, 7, which means this has to be 9 and 4. If this is 4, 7, that means this is 3, 9, so this has to be 8 and 5. So this is a 4, 5. This has to have a 4, 5, which eliminates a 4, 5 in the rest of the box because we have two cells that have to be 4 and 5. So therefore, these can't be 4, 5. This can't be 4, 5. This can't be 4 or 5. So we have 1, 2, 3, 6, 1, 2, 3, 6, and 1, 2, 3, 6 here. Okay. I don't know if this helps much, but we know one of 1, 2, or 3 is here. We know one of 1, 2, or 3 is here. Therefore, there's a 4 or a 6 here. But it could be 6 and that's 4. That's fine. One of 4, 6 is here. No, this can't be 4 anymore. Don't know why it's getting that. So this can't be 4. This can no longer be 3 and 7. If this was 3 and 7, that would eliminate both possibilities for this 12 cage. So this can't be 3, which makes this not 7. Hmm. Excuse me. Hmm. If this is 4, this is 9, which means this is 5, 7, 9. Hmm. Hmm. We know the 8 is one of these two. So this has to be, okay, if this is 4, 7, this has to be 3. Otherwise, this is 3. So there's no 3 also in the rest of column 5. There's no also 6, 7, 8, and 9. So this cannot be 6, 7, 8, and 9, or 3. So it's 1, 2, 4, 5. This is 1, 2, 4, 5, and this is 1, 2, 4, 5. I don't know if that tells us anything. If this is 3, 8, this becomes 5, 7, and therefore this is 9, 4. So this cannot be 4. Otherwise, this is 4. And so therefore this can't be 4. So this can't be 4 either way there. If this is 5 and 8, so the only way, okay, if this is 4, 8, and 9, this has to be 5 and 8. So therefore this can never be the 8 or the 9. This cannot be the 8 then, if that's the case. If this is 4, so it could be 4 or 9 though. That's fine. We know 4 is here. We know 5 is one of these two. Hmm. One, 2, or 5. This is the red one. This is the blue one. Not given much else. The 6 in row 2 has to be one of these 3 digits. Say this is 6, 7, 8. If this is 6, 7, 8. Excuse me. If this is 6, 7, 8, that forces this to be 1, 2, 3, 4. And therefore this would have to be 6. So if this is a 6, 7, 8, that eliminates 6 here. This obviously can't be 6. None of these can be 6, so this would have to be the 6. Which means this can't be 6, which means this has to be the 6. Which means this would be 6. Interesting. So this would be 1, 2, 3, 4. This could no longer be 5 because this would not be bigger than this, if that's the case. So therefore the 5 would have to be here. This can no longer be 5. So therefore this would have to be 5. So again, this can't be 6. This is 4. This can't be 5. So far this is okay. So this can't be 5 anymore. This can't be 6. The 4 is one of these 3. This is 5, so therefore this forces this to be 5. That's 8. Therefore that's 7, 4. Which makes this 9 and 3. So this can't be 4. This can't be 4. This can't be 6. And it can't be 9. So therefore this has to be 8, and this would be 2. So far everything's looking okay. This can't be 2, 3, or 6, so therefore this is 1. Which makes this 2 or 3. This can't be 5, so therefore this has to be 4, 8, and 9. right? Because it can't be 5 anymore. So therefore, this is 4, 8, and 9, which forces this to be the 7. This can't be 4. This can't be 3 or 4 then. So this is 1 or 2. 1, 2, 3. This has to be 4 then. So this has to be 4, which means this can't be 4. So this is a 2, 3, 2, 3 pair. This would be 1 now because of the 2, 3, 2, 3 pair. And we have a contradiction. So from there, we know that this can't be 6, 7, and 8. Man, this is so convoluted. I don't even, yeah, I'm not sure. Yeah. So this can't be 6, 7, or 8. This has to be 4, 8, and 9. So this has to be 4, 8, and 9 now, because we've shown a contradiction with 6, 7, and 8. Therefore, the green is 7, and therefore this has to be 3 to correspond with it. So this can't be 3 and 7. This can't be 3 and 7. So therefore it's 1, 2, 1, 2. So this can't be 1. This is the 3, 4, 5 triplet, so this can't be 3, and this can't be 3. So 3 has to be one of these two. This can't be 4 anymore because the 4 is here. So we have 1, 2, 3, 5, and it's a 1, 2, 3, 5 quadruple, which means the rest of the column cannot contain 1, 2, 3, or 5, which forces this to be 4. So this can't be 4 anymore. This has to have a 6, so this can't be 6. This is a 4. This can't have a 3 here. So one of these is 1 or 2. These can't be 4 anymore. So this is 4. 5 has to be one of these two. The green is 7, so one of these is 7. So this can't be 7, and this can't be 7. Okay. Which means this can't be green. So therefore, this has to be red, which forces this to be green. So therefore, this is the 7. This can no longer be green, so this has to be red. So this is red, which means this can't be red. This is the green 3. This can't be red anymore. So one of these is blue or green. One of these is blue or green. That seems fine. This can't be 3 anymore. This can't be 3 anymore. So we have 1, 2, 4, 1, 2, 4. The 6 is one of these 3. If this is 6, this has to be 5, which would then force that to be 6. Can this ever be 2? If this is 2, this can't be 5, so therefore this would have to be 5, which would mean that this would not have any possibilities, because it cannot be 1, can't be 3, can't be 4, can't be 5 or 2, and therefore it can't be 6. So none of those would work. So this can never be 2. So this is 3 or 6. One of 1 or 2 has to be here. That's actually another way to prove it, that this cannot be 2. If this is not 5, this has to be 5 and 6. So this would be 1, 2, 3, 1, 2, 3, 1, 2, 3. This would have to be 5, which would force that to be 6. Otherwise, this can't be 6. This would be 3. This would be 1 or 2. This would have to be 5, which would force that to be 2. So, okay, if this is 6, if this is 5, this has to be 6. That seems fine. If this is not 5, that means this is 5, which makes that 2, which forces that to be 1. Okay, so if either this is 5, and that's 6, or this is 5, which forces this to be 2, which forces that to be 1, which means this can't be 1, which means this would have to be the 1. So this can never be 1, is essentially what it's saying, right? If this is 5, this has to be 2, which makes that 1. Oh, that's interesting. So if this is 5, this has to be 6. If this is 5, this has to be 2, which forces that to be 1, which makes that 3. And this still has to be 6. So either way, this has to be 6. So this is 6, which means this can't be 6, and this can't be 6, and this can't be 6, which means none of these can be 6. Therefore, this has to be the 6. So this is 6. None of these then can be 6. Therefore, this has to be 6, which means this can't be 6. We have a 1, 2, 3, 1, 2, 3, 1, 2, 3 triplet now in column 7. So the rest of the column cannot contain 1 or 2 or 3. So this is 4, which means this can't be 4. We have a 1, 2, 3, 1, 2, 2, 3, and a 1, 2 here. So that's a 1, 2, 3 triplet again in column 9. So this can no longer be 1, 2, or 3 in the rest of the column. So this is 4, which forces this to be 5, which means this cannot be 5, which means this has to be 5. This can't be 5 anymore. This forces this to be 6 and 8, which means that the blue is 9. So the blue is 9, which means this is 1. And therefore, the red is 8, which forces that to be 2. So this is 8. This cannot be 8. Therefore, this is 3 and 7. So this can't be 7 or 8. So this is the 9, which means this is blue. So it cannot be green. So this is no longer blue. This is green. This has to be then 4, 8, and 9 because there's no 7 allowed. So this has to be 4, 8, and 9, which makes this is a 5, which means this is an 8, which makes this a 7, and this a 4, which makes this 9 and 3, which means this can't be 9. This has to be 8 and 2. This can't be 2 or 3. This is 1. This can't be 1 or 3 because of this 3, 7 pair, so this is 2. This can't be 1, 2, or 3, so this is 4, 5. This can't be 8 or 9, so that forces this to be 4, which makes that 9, which makes this 8. This can't be 4 or 5, so it's 1 or 2. This is 1 or 2, this is 1 or 2. This can't be 8 or 9. This has to be the 7, so it's, yeah, again, this is the green, which means this is not the green, this is the blue. This can't be the blue, this has to be the green. So therefore, this becomes 7, and this is 9. This can no longer be 8, so this can't be 8, and therefore this can't be 2. And this can't be 1 or 2, so this has to be 3, which makes that a 7. Which means this is 9. This can't be 7 or 9, so that now becomes 8. This can't be 8 or 9, so this is 7. No 3 or there's no 4 here. This can't be 7, so this has to be 3, which forces this to be 7, which means the green 7 cannot be either of these two squares, so this has to be 7, and this has to be 5. This is so convoluted. This is 8. This can't be 8 or 9, so this has to be 4, which makes this a 9. So this is no longer the blue. This can't be either, and this is not the red. So this can't be 3. This can't be 7 or 9, so this is 8, which makes this a 9. There's no 4 involved here. This can't be 5 either. So this is 1 or 2. This is 1 or 3. This is 1, 2, or 3. That's fine. 4 has to be one of these two. This can't be 5, so therefore this is 3, which makes that 5. Now we're just probably doing Sudoku. So this can't be 2, 3, or 5. This can't be 5. Whereas the 5 in column 5, it has to be here. So therefore this is 5. This can't be 3 anymore, so therefore this must be 1, which makes that 2, which makes this 3. These can't be 3. So we have a 1, 2, 1, 2 pair in column 3. Therefore, the rest of the column cannot contain 1 or 2. It has to be 3 and 4. This can't be 3, so this is 4, which makes this a 3. This can't be 1 or 4, but again, so this is 6. This can't be 2, so this is 1. These can't be 2. This can't be 1 or 5, therefore this is 3. This can't be 2 or 3, so this is 1, which makes that 2, which makes that 1, which makes that 2, which makes that 1, and that's 2. Therefore, this is 1, and that's 2. This is all because of Sudoku. So this can't be 1 or 2, so this is 3. This can't be 1 or 3, so this is 5. The 2 has to be one of these two. Has to be that one specifically because this one eliminates that. Therefore, this is 4. This is 6, and we finally have a 1. Wow! Not easy at all. No, 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 no. This is not easy. I don't know what people are saying how this is easy. Unless they basically made a shortcut, or unless they found a shortcut, which is possible. I mean, I don't always get all these things. Oh, this was convoluted. But maybe that was just the approach I took. Either that or people just basically made an assumption that was bad. But I could have just missed something too. Wow. Huh. I'm just trying to think like how you could have cut this down. How this could have been easier. It might have been just I missed something. Um well, that was fun still though. I enjoyed this. Because it gives you a lot of things that you have to think about, right? And like you have to but yeah, the way that I approached it at least, it was not easy at all. Maybe there was a easier way of figuring this out. I'm not sure if there is. It doesn't seem like it because every single thing that had to go down was so convoluted to try to figure this out and to try to restrict things that I just don't see a simple way of doing that. Maybe a Fistamafel thing? Maybe. But the thing is, I don't think there's a guarantee that this has to be like a 7, right? This doesn't have to be the same digit for Fistamafel ring, right? And you don't know which one it is, right? Until you basically eliminate all possibilities. I don't know. I'm not sure if there was an easier way. There might have been. There probably was. If everybody's saying this is easy, or the general consensus is that this is easy, but I did not have an easy time of it. I hope you had an easier time of it, or you enjoyed at least my struggling with this. Or maybe you guys saw something that, was not that I did not find. In which case, please leave a comment about it and tell me how uh how I did not approach this correctly, shall we say. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.